Okay, so now, right, what we're going to do is solve this system. So we're going to solve this equation now. You know, the system that is. Okay, so let's do that. Now, I'm going to use, again, substitution, okay? If I tell you to use a certain method, you know, I want you to use that method, okay? You know, I don't know everyone's math background here. I know this, you might prefer one method over another. I mean, I understand that. But again, I want to make sure you can use all the methods. You know, it's always good to have more than one method at your disposal in your repertoire. All right, so for this one, what I did at least, I mean, if you did something slightly different, but still using the substitution method, that's fine. So x plus y we have is 4, right? X plus y we have is 4. What I did was I got y in terms of x. Excuse me. So I got y now in terms of x. Subtracting x from both sides, we get y is 4 minus x. So that's what we get. And so we have y equals 4 minus x. And again, we have one variable in terms of the other. So what we do is we use that and substitute, hence the name substitution method, into the other equation, this one. So we plug it in, right? We have y equals 4 minus x. We're going to plug it into the second equation down here. 4x plus 2y, as we can see, is 4x plus 2 times 4 minus x, right? So, and since 4x plus 2y is 6, this here is going to be 6. But now we're good, right? Because now we basically eliminated y. We now have one equation and only one unknown, x, right? That's what we have. So let's solve this one. So we have 4x plus 2 times 4 minus x, right? This is equal to 6. We want to solve this equation. So what we're going to do is this. Well, we have to distribute the 2, right? We have 2 times 4 minus 2 times x, as you can see. Doing so, we get 2x, right? Because 4x minus 2x is 2x, plus 8. 2 times 4 is 8. 2x plus 8 is 6. That's what we get here. So now we want to get x. Okay, so what can we do? We want to isolate x. X, we get it all alone. We subtract 8 from each side, right? Subtract 8 from each side. 2x is negative 2, right? Because we subtract 8 from each side. And then we divide by 2, as you can see, because we want to get x all alone. We get x is minus 1. So we get x is minus 1. That's great. Now, are we done yet? Almost. We know what x is, but what's y? We know y, though, is 4 minus x. So we substitute, and we get this, as you can see. Okay. So we get that. So the only solution we get is negative 1, 5. Right? So we got x is negative 1. When you plug it in, we got y is 4 minus x. We have 4 minus negative 1, which is 4 plus 1. So we got y is 5. So negative 1, 5 is the only solution. That tells us the system is consistent And these equations, they're independent. They're independent, as you can see. Awesome. So that's what we get. If you did something slightly different, like you could have gotten x in terms of y, you would get x is 4 minus y, or you could use the second equation to get x in terms of y or y in terms of x. That's fine. You know, if you do something correct, I'm not going to mark it wrong. I wouldn't do that. Okay, sorry. Any questions on this? Okay. So now we have the graphical method. And now this method is what it sounds like. You just graph, basically. And we already know, well, since the variables x and y each have exponents 1, you know, if the exponent is 1, we don't write it. We know that the graphs of these are going to be lines, straight lines. Straight lines. They're going to be straight lines. So a solution then would be a point on both lines. In other words, a solution would be a point of intersection. So we want to know if there are points of intersection here. And if there are, the system is consistent. What can happen though is this. The two lines may never intersect. In that case, the two lines are parallel. So in that case, it's inconsistent and there are no solutions. So that's what can happen there. So that's what can happen there. Okay. Now, if the two lines, however, one could be on top of the other. You know, you're graphing the lines in the same set of coordinate axes. One of the lines could be on top of the other. In that case, it's consistent. The system is consistent. However, excuse me, there are infinitely many solutions in that case. Infinitely many. Okay? Hope that makes sense. And in that case, that the system's consistent, but the equations are dependent. This should be consistent. I hate leaving mistakes on here, so okay, there we go. All right, good. All right. So now let's consider what do you call it? Desmos. Okay, so what I'm going to do now, well, it's in the slides and the notes you have in front of you. We're going to graph these using Desmos. So let me get to Desmos now. Desmos, again, the website is here. So let me get to that. Okay, so let me do that. So now I'm going to share the site with you guys, so with everyone, excuse me. Here it is. All right, here it comes. And again, so here we have this. On the right here, you have login or sign up. You could sign up if you want to. You don't have to, but you could. Basically, if you click the sign up, it'll ask, you know, you can connect it with your Google or Apple account if you have one, either one. Or you can just sign up with your email address. Either one, it's free to do. I mean, what's good about signing up and logging in is you can save your graphs that you make. And you can still graph in it if you don't make an account, you just can't save them. It's free to do. I mean, do you have to make an account? No, but you know, you could. As I said before also, wait, sorry, getting ahead of myself. If we click on Math Tools, here we can get the graphing calculator. But I think I said this before, you can download the app onto your smartphone. It's nice, it's graphing, so you can graph things in your smartphone. And you get calculators and stuff. So we click on graphing calculator, and you get to this. So what you can do is you can type the equations that you want graphed on the left side in these text boxes. So for instance, I think in the notes, let me see, one of the equations were 2x minus y is 5. As you can see, right? That's what we get. 2x minus y is 5. Okay? And what's nice is you can see is you don't have to get y in terms of x. To get the other equation you could put in, notice below this, the cursor is changing, right? Click, as you can see. So from here, we could type the other equation in. Oh, wait, how much? All right. Let me just quickly stop the recording because it's going to get too, there we go, there we go. All right. So we have 2x minus y is 5. The other equation, where is it? Oh, there are my notes. 3x plus y is 10. Couldn't find my notes for a second. 3x plus y is 10, and it's graphed. And you can see the point of intersection. If you really want to if you want to zoom in, what you can do is click on the plus and minus on the top right here. As you can see, zoom. You can also click and drag the graph, like so. And you can see that 3, 1. So that's the point of intersection. Even if you move the graph, as you can see here, the numbers from the axis are still there, so you can still see it. So we have the point of intersection, which as we can see from the graph is 3, 1. Oh, there we go. Right. Okay, so we get our solution. You can also, let me just say this, I said this for the other class. What you can also do, if you click on this wrench icon here, graph settings, we have x-axis, see? We have y-axis, see? As you can see. X-axis, y-axis. That changes the viewing window, I think it's called. You know, kind of like in a graphing calculator. The other stuff here, radians, degrees, I know we did trigonometry, but don't worry about that. That's only when you graph the trig functions, but we don't know enough about them to do that. You know, you have to extend the definition beyond what we did. And if they do that in pre-calculus, you know, Math 105 here at Suco. So, all right, so that's good with Desmo. So are there any questions about this? Again, since we're in the online class, I'm not really going to focus too much on the graphing part. I mean, you could always use it to check your work. I mean, in class, I would have you graph by hand without a calculator, but I'm not really going to focus on that too much. That's also why I'm teaching another method after this, which is elimination. And that, I think you'll like also. Let me stop this. So I'm going to get back to the notes. Here we go. Okay. So let me see. I think we covered that, and that's good actually, because we have less than a minute. We did this. You can see the screenshots are here. So as you can see, we got 3, 1. See? So here, actually, I'll start from example 5 next time. So this is where I'll start. This is good. This is where I got up to in the other class, because we have about a minute left. So